In 5.4, we're going to practice some integration, mainly using the power rule for integration. And here it is. If we integrate a power, we simply add 1 to the exponent and divide by the new exponent. And of course, n is not equal to -1, because that would make this denominator 0. All right, so this is the power rule for integration. Okay, so let's apply that to number 1. In number 1, we're going to integrate term by term. All right, starting with the first term. So we have 2, and here we're going to apply the power rule right here to x to the 5th. We add 1 to the exponent, divide by the new exponent. And now apply to the second term. Add 1, divide by the new exponent. And remember that the integral of a constant is the constant times x. Okay, here we can just reduce a little bit. Maybe I'll do that. In the second example, we have to rewrite this integral as a power. All right, so let's do that. First of all, let's write the denominator as x to the 1/4. So this is the integral 5, and let's bring that up as x to the -1/4. So now we have a power, and we can apply the power rule. So we're just going to add 1 to -1/4. So -1/4 plus 4/4 plus 1 is equal to the exponent 3/4. And now we're going to divide by 3/4, or that's the same thing as multiplying by the reciprocal, multiplying by 4/3. In the third example, we want to rewrite the integrand as a sum of powers. So what we're going to do is we're going to divide by this term in the denominator. Okay, so we'll rewrite square root of x as x to the 1/2, and then we're going to divide each term by x to the 1/2. So we'll have a sum of powers. All right, so let's do that. So first step is rewriting. So here we're going to subtract 3 subtract 1/2. That's 6/2 subtract 1/2 is 5/2. Here we have x to the 1, that's 2/2 subtract 1/2 is 1/2. And in the third term, we're just going to bring x to the 1/2 up, and that would be bring it up to the numerator as x to the -1/2. So that's our rewriting step, and now we're going to integrate applying the power rule. All right, so let's do that. So we have 4 and x to the 5/2 plus 1. That's 5/2 plus 2/2 is 7/2. Divide by 7/2 or multiply by 2/7. Here we have 1/2 plus 2/2 is 3/2. Divide by 3/2 or multiply by 2/3. And here we have -1/2 plus 2/2 is 1/2. Divide by 1/2 or multiply by 2. All right, so that's the antiderivative right there. All right, in number 4, okay, here we're not going to apply the power rule. This is the derivative, we recognize that this is the derivative of tangent. So the integral of secant squared x is tangent x plus c. In number 5, we have what's called a definite integral. We have limits of integration. All right, so these are called, this is called a definite integral. And the 0 and the 2 are limits of integration. So we're going to evaluate this. First, let's get the antiderivative of 2x plus 3 using the power rule. So we have, for the first term, 2x squared over 2, or just x squared. And for the second term, we have the integral is 3x. And we're going to evaluate between 0 and 2. So first substitute in 2, and we have 4 plus 3 times 2, that's 6. And then substitute in 0, and both terms will be 0. So this evaluates to 10. In number 6, we're applying the second part of the fundamental theorem of calculus. Let me just make a little correction over here. Okay, that should be cosine t squared dt. So we're taking the derivative with respect to x of this function. This function depends on x. It's the integral from 2 to the square root of x of cosine t squared dt. And according to the second part of the fundamental theorem, well, let me just write it down here. Okay, it goes as follows. The derivative with respect to x of f of t dt from a to x is simply equal to f of x. All right, so that's the fundamental theorem of calculus, part 2. In this case, we are integrating from 2 to square root of x, so here we have a function of x. So we're going to apply the fundamental theorem with the chain rule. So simply substitute in this square root of x into t squared, and we have cosine square root of x squared. And now multiply by the derivative of the square root of x. That's 1 over 2 square root of x. And that's it. So let's just rewrite this. Square root of x squared, write it as cosine x, multiplied by 1 over 2 square root of x.